All right, so I hope everybody had a good spring break. Wasn't long enough in my opinion, but all right. Okay, so this is on. Great. So I've heard back from I heard a bit of I heard back from the TAs who were covering for me. And I feel like everybody needs a bit more practice on strings. Hold on a second. I don't know why this is just simply just falling out of here, so you really... Come on. Really is not just going in there. Hi there. Yeah, it's just not screwing into here. I don't know. Just, I've got it in now.
Oh, okay.
Just, it's part of the reason why I hate VGA cables so much. All right. So, I just posted your latest homework about 10 minutes ago. I wrote it last night, but I didn't upload it. And then I've uploaded it now. Your next homework is one that was at the one that I saw that I was at the conference I was at, and I'm like, this is totally a cool assignment, so I'm going to steal it because my students need more work with strings. And this one is, as you'll see, a program where you are creating the pronunciation guide for Hawaiian words. So given a Hawaiian word, you tell me how to pronounce it. So we're going to go ahead and review strings, especially since it's been like maybe a week since you've been here. Plus I want to go over the enumerate loop. And I suppose that's as good a place as any to start. All right, so let's talk about the different ways we can iterate over something, like a string or a list, right? I believe you covered strings a lot, and then you got a bit into lists, but you guys wanted more on strings, right? All right, so on Thursday, by the way, I fully plan on there being in-class exercises for you guys to do. So, you'll do some in-class exercises and turn them in that will go over lists and strings. So, okay. Okay, so we're going to go ahead and put this into ITP. How to iterate.
Oh, the only other note was that if you did that one page from the exam quiz in the lecture we had right before break, you'll get it back in your lab section.
I've got all of them, by the way, so.
Okay, well, you get that. And then if you bring that with your exam,
Well, I'm going to hand them.
it's better to take it to your TA in your lab section to get it updated.
Yep. So. All right. So we've got a couple different ways. So we've got ourselves maybe so let's go over the different ways we can iterate over a string. So let's go ahead and create a string. S is equal to hello, comma, world. Right? Now we've learned a couple different, the way we typically want to iterate over something is that we go through it letter by letter. We just use a for loop. In fact, that's how what we pretty much have to use to iterate over a string unless we use a while loop. Okay, so for a letter in S, right, I'm just going to go ahead and print the letter. Right, and that does what we'd expect it to do. It just prints out everything each letter at a time, right? Each character of that string at a time. Okay, nothing too bad. We could go through it with a while loop, but to use a while loop, we have to go over it using the indices of everything, right? So, so we would create something like I is equal to 0, while I is less than S dot or sorry, s len s, while I is less than the length of s, print s I, print the ith letter of s, right? So first print the 0th, then we'll say I is equal to I plus 1. So first print the 0th, then print the first, then print the second, then print the third. Whoops. And again, the output here is going to be exactly the same. Hello world, hello world. All right, we've printed hello world twice, right? Of course, we can do that with a while. So you can do that with a while loop. And I'm just reviewing the different ways we've learned to iterate over stuff. So this is the second way, but we rarely use that. The other way to do that is to use I in range of len s. So use a for loop like this. And this covers the range 0 up to, but not including index length s, right? The valid indices for hello world are, let's go ahead and number them out. 9, 10, 11, right? So it's 12 letters long, 12 characters long, right? But they're, so it's 12 characters long, and the last one is, and let's go ahead and just put this over here. Oops. So 10, 11. It's 12 characters long, so the invalid indices are 0 to 11. Okay. And then print s I to print the ith letter of s. Right? Does the same thing. Now let me just see one thing over here. Yep, okay. So one thing that you can do in lists but you can't do here is, remember, strings are immutable. You can't change, so we're going to learn how to change individual things in a list, but you can't change an individual thing in a string. Anytime you're doing something with a string or creating a new string, you have to create a new string. Whenever you modify a string, you're not actually modifying it, you're creating a new string to work with. So I just want to point that out. All right, so a lot of times, though, this is a bit unwieldy, right? A lot of times you're like, I just want to go over this thing, right? Over the valid indices one at a time, and I don't want to have to grab the letter like this. I don't want to have to do letter is equal to the ith letter of s, print si, print I and letter, right? That would say the index 0 contains, right? Index 0 contains H, index 1 contains E, 2 L, 3 L, 4 O, right? All right, everybody see what I'm doing there? All I'm doing is just printing, I'm grabbing the ith letter of S. So first one is H, then I'm grabbing E, then I'm grabbing L, then I'm grabbing L, then I'm grabbing O, then I'm grabbing the comma, and I'm just assigning it to letter and then printing it out. But that's actually pretty common, where we want to use the indice and the thing in the index. So what we also, so if you want to get both of those things at the same time, we can do this. For index, comma, letter in enumerate S. So what enumerate does is that it combines basically this loop and this loop. You can go both. You simultaneously go over both the index and the letter and the thing in it. So we can just do print index letter, and I'll just go ahead and do a print over here to just kind of create a divider over there. And it does, okay, we're going to go through each thing one at a time, and we're going to go and say index 0 is equal to H, then 1 is E, then 2 is L, index 3 is L, index 4 is O. So this allows you to go over both things at the same time, both the index. So that way, so both the index and the things inside of it, inside of whatever you're iterating over. This works also for lists, right? This works for anything you can iterate over. And I just bring it up because, you know, it's kind of a useful operation there. All right, so let's go over, so let's do some more practicing on writing some string functions that might be useful for and this will help develop some techniques that are useful for your homework. So let's go ahead and say I want to grab, let's create a function called only vowels, which will take in a word, right? Take in word, returns only the vowels, right? So it's going to return it without the consonants, right, or anything else in there, right? So this will return only the vowels in there. All right. So for this, right, we are basically doing a running basically string, essentially. We're accumulating into a string. We're building a small string. Much in the same way that, like, if we're doing a running sum with a loop, right, we'd be, you know, accumulating stuff into a sum, right? For instance, if I were doing something like this, so just for example, total is equal to, total is equal to 0 for I in range. If I wanted the sum of all even numbers below 100, right? I could just simply do total is equal to total plus I. And that would give me that sum of all numbers, right? So much in the same way that total acts as an accumulator, acts as basically the sum in that statement, here we're going to create a variable called output. And I'm going to set it equal to an empty string. Why do I set it equal to empty string? Because that's essentially the same thing as saying total is equal to 0, right? It's the identity operator for, it's the identity value for basically string concatenation. Whatever I add to it, its result is itself. All right? So what we're going to do is that we're going to iterate over this word, and if it's a vowel, we're going to add it to our output. And when we're done, we're going to return the output. All right? So for letter in word. Now I know that this is the way I want to iterate over my word because I just care about the individual letters in it. I don't care whether or not there's a, think about that for a second. I don't care what the index is, right? So I don't have to get the range or anything. When I care about the, the indices or where something is at, that's where I'll want to get the, use the enumerate. So what I'll do is to basically say, I'll say if letter, so there's a bunch of ways I can check if letter is a vowel. First way is this way, right? If letter is equal to A or letter is equal to E and so on and so forth, right? Checking against all the vowels. That's one way. But a much more concise way is by using the in operator. So if letter is in A, E, I, O, U. So if this letter is in this string over here, right? If this is in the string over here, great. Then it's there. So output is equal to output plus letter. And here we're adding strings together, which does string concatenation. Right? So let's take a look at this. Print only vowels, hello. And that should give us just the vowels. Oh, unexpected end of file. What did we do? Line 18. Expected. What in the world? Oh, one more parenthesis. EO, right? Those are the only vowels in there. All right. But what about, you know, that? I'm not getting the vowel from that. Now, this is why we use two upper and two lower a whole lot, right? If I have a capital E there, it's not grabbing the capital E. Why is it not grabbing the capital E? Because, well, I'm going through every letter in the word, and I'm asking, hey, is it one of these things? There's a couple ways I can deal with capitalization as well, okay? The first way is I can just simply say A-E-I-O-U, right, like that, right? And that will solve that, right? Saying, hey, if it's any of those, if the letter is in this entire string, right, then great. Another way to do that is that I use one of the many string functions we have. Right. So to lower, let's see, lower? Nope. It's just lower, I believe. Yeah, it's different in different languages, so I have to always double check. String.lower, we'll put it in lowercase. And then it will do capital E-O. But wait a second, if we're turning letter into lowercase, then why is it getting added to an uppercase? Right? Why is it getting added to uppercase over here? If letter dot lower in A-E-I-O-U, we're going to go ahead and add it. But we're adding a capital even though we're doing letter dot lower. Any ideas why that's going on? Yes?
Because the letter is a string and strings are immutable.
Yep, letter is immutable, right? We can't change letter, right? What this does is that this doesn't make letter lowercase, technically, even though it's a useful way to think about that. What it does is that it creates a new string that is the value for that has all the values that letter has, but now lowercased. That makes sense to everybody? It creates a new string there. It doesn't change letter's value. Right? You can't change a string. Okay. Oopsie. All right. Okay. Yes. Let's see. It's a great question. I'm not sure. No, you can't assign it to a function call, right? Because this is basically creating a variable here and setting it equal to each item in the word. So over here we can do letter dot lower. Over here, if we wanted it to be all lowercase, we'd have to do a letter dot lower over here as well, or we'd have to say over here, letter is equal to letter dot lower. And here I'm replacing the old letter with the old string with a new string, right? Right? All right. So, yes.
Could you do like to make everything happen? Could you do word.lower so everything you type in?
I could do it to word.lower. But if I want to preserve, yeah, I totally do. And it depends on whether you want to preserve your capitalization or not, right? In this example, I assume that I want to preserve my capitalization. If I don't want to preserve my capitalization, I could just simply do word.lower over here. Right? That was the question, could I simply just do that? And the answer is totally. Okay. Now, there's a bunch of other useful bunch of other useful operations for strings. Starts with is useful. Now, one that you won't really be able to use, that you might be tempted to use for this latest homework, this pronunciation guide, is replace. I highly recommend not doing that because it's not going to work. the replace function will not work on your latest homework, but it's still a useful thing to do, which is that it replaces all the values in the string that are one thing to a new value. Let's see how that works. Out. Def blank vowels. So here we're going to take a word, and what I'm going to do is that I'm going to create a new string where all the vowels are replaced by a dash. Right? We're going to go through this once with a loop, and then we're going to use a function call to solve this problem the second time. Right? So in other words, I want to turn something like good into G dash dash D. Right? I'm just going to dash everything out. Okay? It's a silly exercise, but again, I'm trying to show you guys some string functions over here. Okay? So output is equal to blank. So for a letter in Word, if letter in A, and again, we're just doing if letter is in A, E, I, O, U. We're going to do something different here. Output is equal to output plus. And here I'm adding a blank instead, right? If the letter is A, E, I, O, U, we just simply take our output and add a blank to it. But we're not done yet. And the reason being is that if we leave it as is, all that's going to happen is that we're going to return, let me just do this. So hello, we're just going to return 2 blanks at that point. Why? Because a computer, again, is going to do exactly what you tell it to do. What I just did there was for every letter in the word. If the letter is an A, E, I, or U, we're going to add a blank. And that's it. That's all we told it to do. We didn't tell it to do anything else. So in this case, we need an else statement, right? Else, if it's not an A, E, I, O, U, output is equal to output plus letter. So if it's a vowel, add a blank. Otherwise, add in a letter. And there, we get H blank, LL blank, right? All the vowels have been blanked. I suppose an underscore might be better. Very easy to change it to an underscore. There we go. All right. We can do the same thing though with a well-written replace operation. So here I'll do I will just simply do this one and call it blank vowels 2, right? And we can just simply do return word dot replace. Let's see. Does this work? No. Let's see what replace this. Returns all occurrences of substring replaced by new. Got it. So here, so let's actually just see that in practice before we try that out. Because I want to make some intentional mistakes here, right? Just to hammer home some concepts that I've been saying, right? So let's go ahead and watch this. So word is equal to hello. I'm going to replace all the L's over here. Let's go ahead and say word dot replace L with capital L. Right? Everybody see kind of how that works? You tell it the first thing you want is the thing you want to replace. The second thing is the thing you want to replace it with. Right? Doesn't have to really make sense. Right? I can do pretty much anything here. Thumbs up emoji. Let's go ahead and see. Right? Remember, Python 3 is Unicode friendly. So let's just go ahead and grab up grab the thumbs up emoji there. Okay. Let's see. Am I using Python 3? Yes, I am. So there. Totally. So yeah, you can, again, it's Unicode. And this is very important about Unicode, so I'm going to totally do a digression over here, which might help you with the extra credit that on the assignment that was due last night. If you still want to do the extra credit, you're more than welcome to. We'll take it, even though you'll technically be late, because I really want you to try that ROT 13 extra credit, okay? Because this gets me into a topic that's really exciting. Right. So what, right, again, I can just simply do this for anything. Letter is equal to the thumbs up, so it says literal character. Oh, right, because I have to put it in a string, right? But except that, okay, here's the thing, though, right? I can totally do this. 2 thumbs up is equal to 5. Wait, no, invalid character in an identifier, so I can't do that. Darn. Okay. Be fun if I could. All right, so letter is equal to the thumbs up, so letter, it will just print out that string, okay? Now that string has an ASCII value. Again, everything in your computer is just a bunch of ones and zeros. We haven't really gone into detail about how it figures out what ones and zeros are, because that's low-level stuff, and it's mind-numbingly boring for the most part, in my opinion, especially in this intro-level class. Instead, it's much more useful to deal with non-binary information. So we're going to go ahead and see, like, this letter has a value, has what we call an ordinal value. Like, what order does letter appear in Unicode? And it is 128,077. So in other words, it is in terms of our computer's alphabet, right? Our alphabet is 26 letters long. It has, so C is the third letter of the alphabet. This is the 128,078th letter. Why the 78th? Because, right, index 0 is a thing, right? So, but we can go ahead and call it the 128,077th because, just for simplicity's sake. Okay, so the question is, like, what is the letter that comes after thumbs up in the alphabet? I mean, I'm kind of curious now, right? Okay, so I suppose, right, if I'm getting a number, I could add 1 to it. But I'd like the 128,078th. So I need so there's a function that gives me the letter that gives me the letter. Given a number, it gives me what letter in the alphabet that is. So it makes sense that thumbs up would be followed by a thumbs down, right? So, right, so here I'm just plugging in 128078, right? That's the thumb down because we knew that the thumbs up translates to the 128,777 or 77th, right? So now we want the 12878th, right? Thumbs down. The 79th is applause. I'm glad it wasn't something rude. So that's pretty cool, right? So to figure out what something's value is, though, given a character, you use the ord function or the ordinal function. It gives you, so again, ORD for let's go ahead and do applause. Control C, whoops. Control Shift C for ORD. Oops, here we go. And got to put it in a string symbol, right? To say that's a string literal. 128 and 079 gives me that value. Now, we can figure out, now if you want to now CHR does the inverse, which is given a number, 128079, it gives you the character that's associated with that. Now, by no means are you expected to memorize any of that, right? What number goes to what emoji, right? I'm not even going to ask that as an extra credit question. That'd be just worthless. However, it is sometimes useful to know a couple. For instance, I know that that the value for 97 is A. I just know that because because when we're working in encryption, that's actually really useful to know. So right now, A is the first letter of the alphabet, right? But for our computers, it's the 97th. Technically the 98th because we start counting at 0, but for simplicity's sake, again, I'm just going to call it the 97th so I don't have to add one each time. Make sense? And I'll call the very first thing the 0th as a result, right? It is the 97th letter of our computer's alphabet, which is Unicode. Now, Unicode's a very special alphabet because it will contain everything, right? I'm just going to add 1100 there, and that comes with, I have no idea what that is, right? It comes up with stuff over there. And this is an empty space with the hexadecimal value of 2BBD, right? So that's empty. It's still unassigned, right? You can actually petition like the Unicode consortium to say, hey, this value, you should totally add this emoji to, to this. Like that's like a side project for some congressmen for their fun things to do. I think. Right, some of these don't actually have values, right? Is that almost like the Triforce there? Almost. But all these things basically have different values. But most of the time we're just concerned with regular letters. Most of the time we're concerned with just CHR, with basically dealing with, CHR, 97, right? And the reason is that because typically we're working with just text, just regular English letters. Okay? So hold on to that thought, and we will totally be coming back to that in just a bit. Okay? So, okay. So back to the replace function, right? So I can totally replace anything, replace anything with anything I want. So I could do, let's see, do I still have Word? Yes, hello. Word.replace, I can replace all the A's, all the E's with, two L's, right? So it works for by the way, so it's saying replace this substring with this substring. It's not a one-for-one replacement. It's saying replace all the E's with two L's. Right? Make sense? If I wanted 2 thumbs up, I could say 128,077. I somehow memorized that, but again, if you type it out enough times, you're going to memorize anything. Times 3. Right? So replace all the E's with 3 thumbs up, right? Okay? But wait, word.replace, we just replaced the E with 2 L's. Why is there still an E to replace? Strings are immutable, right? The replace operation replaces the thumbs, it creates a new string with the E replaced, and this creates a new string with the E replaced and the thumbs up. Strings are immutable. Okay, so let's go ahead and finish our function, and then we're going to talk about encryption. Okay, so we're going to replace all the A's. So we can't just simply do, word.replace all the A's with blanks, right? Going back here, we're replacing all the vowels with blank. We can't simply just do this. And now this is where the insert key comes in a lot of very useful. A, E, I, O, and U. Right? Return word. Right? All this is going to do is just return the original word back to us. Blank vowels 2. Right? Why? Because strings are immutable. All I've done is said, create a new string where I've replaced the A's with blanks. Create a new string where I've replaced the E's with blanks, right? This is very important here. So the way I do that is I can do word is equal to word.replace like this. You will learn, by the way, a way to do this in a couple weeks, you're going to learn about regular expressions and ways to do this basically in like one line that is not messy and is actually readable. We can do this in one line. I'll show you in a second, but it's going to look very, very messy. And there, all we're saying is we're going to create a new string with all the A's replaced by a blank, and we're going to store it in Word. Then we're going to take Word, replace all the E's in it with a blank, and store it in Word, and so on and so forth. Okay, right? So we keep updating our result. We keep replacing our old string with the new, our old variable with, and have it hold the new string. Okay. In effect, it seems like we're changing it, but we're not. We're replacing it, and that's kind of it's a subtle difference, but it's important to kind of get a good grasp for it. Now, because this result, now going back to how we do this in one line, I'll just go ahead and show you, and I'm going to tell you should never ever do this because it's ugly. Okay, we can just do it in one line because remember, word dot replace. This creates a new string, right? And if it's a new string, that means we can use a function call on it because strings have inbuilt functions. So then I can follow it up with dot replace E, right? And that calls the old string. So that calls the new string that we just produced, right? Right. This is kind of, if we don't need the parentheses, but that's kind of what it's doing. It's saying, hey, whatever gets yielded from this, from word.replace a blank, we're going to replace E's now, right? And you can kind of see where this is going right after the first step, right? Control C, Control V, Control V, A, E, wait, no, skipped one, I, O, and U. And a small shout out to my toddler who has learned 2 of his vowels so far. He knows O, and he can recognize an O and an E now, which is fantastic. He knows as many vowels as years old, so. All right. So blank and blank. So there. Again, though, why is this bad? Why would I rather you do this as opposed to this one? Sorry? Readability, right? I cannot read the whole line on my computer screen. Now, part of that is because I use this bumped up font, but you'll notice that basically as I've been typing, there's this line here, which you may have assumed is just this weird artifact that's on the projector. And I'm here to tell you that's actually not an artifact. That's intentional. That is something that I produce over here. This is a line that's produced, I think, on the 79th character. No, 72nd over here. 72nd character. It's either put on the 72nd character or right when you go up there to 80, depending on your IDE. And it says, hey, you kind of want to cut off here for readability's sake, right? Don't go past this line if you want a line to be readable. It's just it's not going to give me a warning or anything. It's not going to yell at me. It's just saying, hey, you want it to be easy to read in a terminal, which is typically 80 characters across or 72 characters across, depending on what you're using, then you might want to stop typing over here so it doesn't break the terminal, right? Because believe it or not, you might end up working in a terminal one of these days. All right. So readability is the only reason not to do this. But it's an important reason. Why? Code gets read more than it's written. I wrote this once. Well, technically I wrote this 3 times, but every time I wrote it, it got read like 100 times, once by every person in this class, right? So, code gets read a whole lot more. So, that's why it's important to name things, give things variable stuff. All right. So let's talk about our first foray into security, shall we? All right, and you might think strings and security, what do those have in common? And the answer is everything, because my secret messages are always, and any information you send, such as credit card information, is stored as a string typically, right? your personal information strings. It's text. It's got to get sent over at some point, which means we need to make this, that if we want that information to remain secure, it needs to be unreadable. Now, most algorithms use, a lot of places use something that's like based off of private key, public key encryption, and we aren't going to get into that right now. We are actually going to learn about the state-of-the-art security systems for like 2nd century. So not anywhere from modern day, but it's pretty useful to understand this right now. It was around the end of World War II when it became completely impractical for humans to try to crack codes anymore, around the time, and basically where everything got shifted over the machines. Also, there was a philosophical change that the way to keep your messages safe was to make it so that the generated encryption, you didn't keep the encryption scheme secret. Like if I encrypt a message, it's perfectly fine if you know how I encrypted it, but so long as you don't have my secret key, you can't open it, right? That's the key there, right? So it used to be basically that, the way if you wanted to keep a secret message hidden, right, you'd basically also make sure that nobody knew the way you sent this. Now, this actually is terrible. Like, okay, let's go back to medieval times and talk about, like, let's say you are an architect and the king wants you to build some secret rooms and secret passages in the walls so he can go around and stuff, or some secret exits. What's the best way to keep a secret? How many people can keep a secret? One. Only one person can ever keep a secret. If you have two people, if there are two people keeping a secret and it needs to be kept a secret, one of them needs to die. So, and that's exactly what would happen. Build the secret plans, give them some gold, have a quote-unquote bandit attack happen, and and then maybe get some of that gold back and use some of the rest to pay off the bandit. But either way, that secret's now safe, right? So it's very important to us, if we want to go into security, that the security systems remain open, right? And that what keeps everybody safe is the keys and the mathematical processes behind them, right? We don't want coders being killed because they know too much. All right. So let's talk about state-of-the-art encryption for the 2nd century. So this was basically Roman times. Now the Romans were pretty awesome at conquering stuff. They had huge armies. They had a lot of discipline. They had plenty of tactics. They were pretty, for want of another word, badass. They were pretty good. But they didn't necessarily have a great view of non-Romans. They called anybody who was non-Roman a barbarian, which meant that they didn't speak Latin and everything sounded like barbarians, right? So so sending orders in writing wasn't necessarily. You didn't necessarily need to encrypt that, right? You didn't need to scramble it or send any secret messages because, literacy wasn't exactly a high priority. Public education hadn't really taken off as a concept. So, at least among the quote-unquote barbarians, right? Rome had its share of uprisings. So how do you keep your messages safe from people who can actually read? And the answer is to make it readable only to some people who know the secret code. And therefore we go into the Caesarian cipher named after Julius Caesar. Okay? And the Caesarian cipher was pretty simple. What we would do is that it's what we call a classical rotation cipher, where what you would do is that you would rotate each letter of the alphabet 3 forward, right? So, what we would do is that we would replace all the, so what we do is that we would say, hey, A is the 97th letter of the alphabet in computer science, right? So, right, ord of A is that. So all the A's would be replaced with the letter that came 3 after it, D. All the B's would be replaced by E's, and so on and so forth. Z would be replaced by the letter 3 after that. What's the letter 3 after Z? C. It's circular. So in that case, we make it circular. So Z's would be replaced by, Z. So let's go ahead and write something that does our encryption. It does the Caesarian cipher. Okay? And this will end up being pretty interesting, but I'll break it up into multiple steps for us. All right? We want to take a message and we want to create a Caesarian cipher. We are going to create a encryptor and we're going to create a decryptor. Okay? So encrypt Caesar word. And what this will do is that this will encrypt it in a Caesarian cipher. I like to do ciphers in a lot of my classes, mainly because it's interesting, because code breaking is very interesting, and even a rudimentary code is pretty, even something basic like this that can be, you know, pretty basic, easy to crack, you know, it's still pretty useful. Right? There's two types of, essentially you can classify encryption schemes into two classes these days. Those to keep your nosy roommates from reading it, and those to keep governments from reading it. So, you know, this is nosy roommate, right? But there's not really a middle ground. It's either strong enough to keep your roommate out or strong enough to keep a government out. Okay? This is the former. So what we're going to do is that we want to create an output like we use, right? We've got to take, output. Okay, we want to, create a blank. We want to create our accumulator, and then we want to return, assuming I can start typing correctly, the output once it's gotten all the characters. Okay, and now what we got to do is that we got to go through every letter in the word. Okay. Okay, so for letter in word. Right, and again, I don't care about the index. Okay, let me just go ahead and I'm just writing down what my next what I want to do after the encryption, because I want to tackle one more technique before you before you have to hit your homework. Okay, so for letter in word, what do we got to do? What we got to do is that we've got our letter, and we need to figure out what its value is, right? So its position in the alphabet. So its position is, and I'm going to do this like in a bunch of steps. We're going to do this incorrectly first, and then we're going to just iterate to a correct solution. So let's figure out what is, so pos is position, and that's its position in the alphabet, right? The way we do that is we get ord of the letter. Right? And then how do we encrypt it with Caesarian, right? It's 3 down, right? So all we have to do is say, hey, cipher text is equal to position plus 3, right? And that will give me the number, right? So say this is A, right? Letter will turn into 97. Ord letter turns this into 97. This will give me 100. And now I need to turn that back into a letter from a number. So I use the CHR, right? Turn it into a letter, add 3 to it, and turn it into and that will give me the one that's 3 down from it. Okay? And now we just simply do output is equal to output plus ciphertext. Right? Typically, we call the things that unencrypted are plain text, and then the encrypted portion, the ciphertext. So let's go ahead and try hello with encrypt Caesar, right? And that will give me core. Okay, let's think about that for a second. So L M N O. So that seems to make sense. Right, we just got to check this manually, but it's short. But the nice thing about this one is that it's simple enough. What about O? O, element O, P, Q, R. So P, Q, R. So that's 3 after. So that's great. So this seems to be working out just fine. Yeah, I know. We've got, so let's go ahead and try another word, right? Let's go ahead and do apple, right? right? The classic one, attack at dawn. Oh, that's a bit weird. Why is it a bit weird here? Yes?
You can do the spaces.
Yeah, the space, it affected the spaces as well. Interesting. So typically in encrypted messages, what we do is that if it's not a letter, we skip it. We'll get to that in a bit. But an attack at dawn, it works. Let's go ahead and then do one more. What about zebra? What about zebra? It's curly brace Hoyd. Uh-oh. Well, why is it giving me a curly brace? Well, let's go over here again, Python 3. Let's go ahead and see what's going on there. So, ORD of Z is 122. So CHR 122 is Z. 123 is open curly brace. 4 is bar. 125 is closed curly brace. Right? Uh-oh. We need it to be circular for the range of letters. All right, so let's go ahead and tackle. So we've got two missed problems here. First, if it's a letter, we only want to encrypt our letters. So, okay, for letter, so if letter dot is, let's go ahead and take a look at our functions, shall we? Common string operations. Is alpha. Is it is alpha? Let's see. Yeah, is alpha should work. Let's see. Is alpha? Let's see. Has no attribute is alpha. Is alpha. Okay, so let's go ahead and see. Is ASCII. Oh, is alpha with a lowercase a, right? I don't have everything memorized. I make mistakes too. Is alpha. So that says if it's an alphanumeric character. So that means that now for attack at dawn, what it's going to do? It just simply merges everything together. So let's just go ahead and say, hey, if it's an alphanumeric character, we are going to encrypt it. Else, if it's not, we're just going to say output is equal to output plus letter. Actually, that's terrible for encryption to leave your spaces in, because then you know you're trying to crack a 5-letter word and a 3-letter word and then so on and so forth, right? But we'll just leave it in because we're learning here. Okay? So now to deal with the whole wraparound issue, right? We've got to deal with, so let's go ahead and turn this into zebras like carrots. I don't know if that's true or not. I suppose I should ask my wife. She's a zoologist. So let's see. So we got to figure out what to do there. Now, the issue here is that we do actually have a operation for wrapping around, right? It's very useful, and we've used it a couple times, and there's no escaping this in here, right? For instance, we can calculate, hey, what time is it? And the answer is, hey, so let's see, it's 2:55, right? Or also known as 14:55, right? So our hour is 14, right? So what is the time that is, let's say, 11 hours from now? Mod 24. Right now we're in the 14th hour. 11 hours from now would be 1 o'clock, right? Modular arithmetic helps us work around in a range, right? It allows us to wrap around in a range, right? Again, modular arithmetic is just like working with a clock. In the sense that basically it just wraps around with as many hours as as you have for the modulo operator. So that's our first step here. So how can we use the modulo operator here? And it's not necessarily intuitive at first, so I want to get plenty done, so I do want to show you. Now the idea here is that I said it was early on I said it was very useful to know that that its value is 97. And so far all we've been doing is adding adding values. But let's think about this for a second. What if I were to take ord of like my letter? So let's say my letter was H, like in hello, or H, like in hello. And we go ahead and subtract A from it. So ord of H minus ord of A. That gives me 7. Interesting. Right? Let's go ahead and just be more specific about this, or give you a bit more of a kind of let it click into place. A minus A, right? That makes sense. A minus A is 0. What about B minus A? That gives me 1, right? Because B is 1 more than A. What about C? C minus A is 2, and that kind of makes sense, right? If we let A be the 0th letter of the alphabet, then it makes sense that C is the 2nd letter of the alphabet. 0th, 1st, 2nd. I know, that's hacky, but what are we going to do? It's so much easier to start with 0 in computer science. So get used to 0th and 1st, and there being a lot of just instantaneous confusion about and understanding about what that's going to be. So Z minus A is 25, the last letter of the alphabet. Okay, so if we subtract A, we can get back into the range of 0 to 25. Now, there's 26 letters in the alphabet, so what I can do is that I can add 3, right, and that would give me 28. But I can't just do like CHR, right, and that will give me 28. But I don't want the 28th letter of the alphabet. There is no 28th letter of the alphabet. I want the one that's 3 after 25. So what I'll do is I'll do modulo 26. And that will say, okay, it needs to be the 2nd letter of the alphabet, right? 0, 1, 2. 2nd letter. Make sense so far? Right? So here, we subtract A out, and then we wrap around back in. Okay, but I can't just throw CHR2 at my computer. It tells me that it's some weird character. No. Well, we subtracted A out, so what we have to do is that we have to add A back in at this point. So 2 plus A gives me C. So what we're going to do is that we subtract out A to get down into the range of 0 through 25. In other words, so that there's 26 values now, and that we can wrap around it as much as we want. Then what we can do is that we can add 27. Then we can add 3 to that value and mod by 26 to handle the wraparound, and then we add the A that we subtracted out back in. So let's see that in action. So ciphertext is equal to CHR position plus 3, but it isn't just position plus 3. Let's go ahead and say our position is position plus 3. So let's see. So position minus ord of A, right? We subtract the A out, and we'll need to remember to add that back in at some point. Ord of A. I'm putting it in now because I always forget to add in the A. And then I was like, why isn't it working? And then I was like, oh, right, I forgot the A. Add 3 to it. Mod by 26. And then add the A back in. And this handles the wraparound. And now, our curly brace is replaced with the, now our curly brace is replaced with that C. So it wraps around perfectly. So here, right, we subtract A. So now we're in the range of 3, from 97 to 122. Instead of that range, we're now dealing with the range of 0 through 25 inclusive. We add 3 to that value, right? And then we mod by 26 because it's possible that we wrapped around, that we went over, so we'll want to wrap around, right? So this will give me the respective value that I need to wrap around. So now if I do ORD, and now if I add, now this ORD A, this subtracted the A, so I'm adding the A back in so that I go back into the range that my computer understands, right? So this brings it into the range for encryption, and this brings it back out of the range for encryption and puts it into the area the computer can understand. Okay. Any questions on that? Certainly there's a question. Yes.
Earlier you said like C was like the third character for ORD.
Yes.
But doesn't it start with 0?
Yeah. Third, second, it gets confusing when we're talking about that.
Just start with 1 for like my sake.
Yeah, I mean, so it would be the third from starting from 1, second if you're starting from 0.
Okay.
Right. I mean, technically it's always going to be the third even if you're starting from 0 because, right, it's going to be the third thing. Right? But it just doesn't make sense to say that the thing at index 0 is the first thing. It's sometimes easier to say it's the 0th thing, right? And that's just, you're going to be dealing with programmers that have different conventions with that.
And another question.
Yes.
I'm looking at ORD, that's Unicode, but what's CHR?
That turns CHR is character. That turns it into the into the character. So it turns it into the Xth character where X is the number that you gave it. Right? Right, it's the reverse of ORD. Right? If you do CHR and then ORD, it will give you it will give you whatever you put in. Right? They're inverse operations. So now how do we decrypt? It's not as simple as just subtracting 3, unfortunately. Well, first let's go ahead and grab our message. Right over here. Control C. Let's just grab our message over here. Right? So now we want to turn that, say we got this message, we want to turn it back into something we can read in English. Right? So now we need to decrypt it. Now, to decrypt it, right, we just do the reverse of what we did. Now, we added 3 last time, so that would make sense that we should just subtract 3. Let's see what happens. Fortunately, that works in Python. Zebras like carrots. It doesn't work in Java. I've had issues with it doing that in Java. But zebras like carrots. There you go. So all you have to do, right, we say move 3 characters forward here. And in decryption, we say, oh, it was 3 characters, so we change that plus into a minus. We move backwards. We do 3 characters afterwards. Make sense there? Okay. All right. So let's go ahead and just do one thing, one more thing. Let's see. I want the AE glyph. So I want to grab this glyph right over here because let's go ahead and I'm just grabbing this because it's a good example for something that's similar to what you'll need for homework. I want to place all AEs with the single character AE. Okay? Make sense? Now, so any 2 letters, A and E, are being combined into this single AE glyph over here. Okay? Now, this is a bit different than the other ones because we cannot just do the regular for loop that we're doing. we cannot just simply say output, I mean, it's going to start the same. Output is equal to blank, and then it's going to end the same, return output. But we can't just do for letter in word, right? And the reason is because we aren't going to be looking at just one character. We got to be looking at a group of 2 characters, right? Right, you might start writing this and go, okay, for letter in word, if letter is, if letter equals A, wait a second, how would I check what the next letter is? And you can't, because if you care what the next letter is, then you care about position. And if you care about the position, what do you need? You need the index. So here, what we'll do is that we will use the enumerate, because I care about both the letter and the index. You can also just do the range thing, but I like enumerate because it's easy. Enumerate word, right? So here, if the letter is equal to A, then what do I need to do? I need to ask myself, well, what follows it? Right? I need to ask myself, if the thing after it is an A, is an A followed by an E. So if letter is equal to A, and word I plus 1 equal E. Output is equal to output plus AE. Right? Else, output is equal to letter I'm sorry. Now, you may be wondering why I'm grinning, and the reason I'm grinning is because I am thinking of all the ways that this is actually so terribly wrong. So let's go ahead and so actually, this is actually a non-trivial thing, which is why I like it. Replace AE. So what we're going to do is that we are going to do replace A followed by, and yes, I could technically use the replace function, but in your homework, using the replace function is actually not necessarily a good idea. Yes? Sorry?
How do you produce that character?
I looked it up and copy-pasted. That's how I did. Let me just go ahead. Oh. Okay, so first off, that I is undefined. It's actually index. All right. That's our first mistake there. We replaced, what just happened there? We replaced the A with AE. Oh boy. All right. Other thing. If I try hola, string out of range. That's another way that this fails. This actually fails multiple ways, even though it looks really, really nice and worthwhile. So why did it fail? That's because it's out of range. Well, let's think about this for a second. This is the easier thing to fix first, by the way. Well, the letter was A, right? And the word was index plus 1. Oh, we're looking, if the thing after A, but there was nothing after A in hola. So we got a error there. Uh-oh. So maybe what we need to do is we should probably, maybe we should cut down on our range. There's a couple ways to do that. If we want to keep using enumerate, one way to do that is if index equal length. So what we can do is add another condition here. If index is equal to length, or sorry, less than length of word minus 1 and, right? So in other words, so long as we're before the last letter, because that error is only going to occur on the last letter. Great. Okay. Another way to do that is to adjust the range over here in enumerate. Is instead of doing enumerate, you replace this with the range and just don't go up to the last letter. But then you're going to have to figure out how to replace that last letter. Oh boy. Okay. So now though we're getting we've got our issue here where basically we have to do some kind of thing. Now what you have to do in your homework, so this is important over here, and I need everybody to listen to this part. Doing this won't necessarily work for every case in your homework. In fact, it probably will only work for a couple, right? The idea here is that maybe I need to skip it after there. So let's go ahead and create a variable called skip. Skip is equal to false. And let's go ahead and say, so if we need to, let's see, if the letter is, so if we replace the letter, if we replace the A with an AE, that means we want to skip the E that comes after it. So we'll say skip is equal to true, right? Okay, and now let's add in a new condition over here. If skip equals true, skip equals false, set it back to false, and how do we skip? Well, all we're going to do is turn this if into an elif. Make sense? So if skip is true, then all we're going to do is set skip to false because we don't need to skip anything anymore. So hola, and then AEPPLE, Apple. So now that should replace that with that, right? And that was literally with me thinking of something, coming up with something because this was a bit tricky to figure out. There's a couple of other ways to solve this. Let's go ahead and take a look at another way to solve this one. Right? Another way to solve this one is to use a while loop. Okay, so what we'll say is while, we'll set up an I is equal to 0. I is equal to 0. While I is less than length of word. And remember, this was the other way that this was this way to iterate through it, right? Where basically we go through letter by letter. We say, hey, letter is equal to the ith letter of the word, the ith character in the word. I is equal to I plus 1. And we're going to just do the same thing over here. We're going to do something similar here. If letter equals A, right? If I is less than lem word and letter, if I is equal to less, so long as we're before the last thing and the letter is A and word I equal word I, and the thing after a, word I plus 1, right? That's what word that is. Right over here, I plus 1, this is the thing after a, right? If letter is a, the thing at I is a, then I plus 1. Let's see, if that is E, then we're doing something similar over here. But how we control the skipping is actually now a bit different, because because in a while loop we can control how we can manually control how we go through the indices. So what I can do is say the next one I want to go over is not I is equal to I plus 1. I don't want to go on to the next one, but I want to skip it. I is equal to I plus 2. Else, output is equal to output plus letter. Otherwise, just add the letter in and go on to the next letter. So this works just as well, except let's see what happened here. Oh, what did I do? Non-parenthesis. It is literally a rookie mistake, and yet here I am, guy with like over a decade of programming experience, still making that mistake. So don't beat yourself up over any of your mistakes, because I totally make those mistakes too. The difference is that, of course, I just simply read the error message really fast. It said I plus I. Let's see. What did I? If I is less than. Oh, I plus I. Got it. There we go. April. All right. So I think that's enough for today. So go ahead and take a look at your latest homework. You'll get the chance to work on it in lab. I made it due, I think, Thursday next week. So there's plenty of time to work on it. The other thing about it is, again, just take a look at it. Thursday we'll do some in-class assignments that you'll turn in, and you'll be able to work with a partner on. Okay? I also sent out early alerts. And I'm generally pretty aggressive about sending those out in the sense that my threshold for sending it out is fairly low. So just because I like to try to keep people on their toes. Okay.